2. Chapter 2. This chapter is all about types of matter. In the reading that you should have done, there were 3 major types of matter. Anybody remember what they were?
Remember or look at our notes?
Either way works for me. What do you have? 3 big categories. Yeah, Jack. Okay, those were states of matter. That was chapter 3. Yeah, Ava?
A substance, is that one?
Types of substances.
Oh.
Say again? Okay. Solution, suspension, and colloid. Okay, those 3 make up mixtures, which would be our first category.
Mixtures.
And what would the other 2 be? Emily?
Elements.
Mixtures, compounds, and elements. Excellent. So those are the ones we're going to take a look at. And it doesn't matter.
Service people, please report to ILC.
I'm not sure. So when we are talking about those 3 types of matter, it doesn't matter which one it is, we should probably start with a definition of matter.
Whoa. Your hand is like.
Yeah, it's not really staying with me. So, what is matter? Yeah, Brooklyn. Everything. Okay. Could I come up with something that isn't matter?
No. Matter is everything, so if you create something new, that means it's something. So
What if I said something like time? Is time matter?
No.
Okay. Okay, so I need to be able to touch it, all right? An object, a physical substance. Okay. So when we talk about matter, matter is going to be anything that has mass and takes up space. Anything that has mass and takes up space. So if you can touch it, it's probably matter. So your desk is matter. Water is matter. The air in the room that you are breathing, even though it can change how much space it takes up, it's still matter. Light is not matter because it does not have mass. Okay? And it also doesn't take up space. So light and time are like the only 2 examples I can come up with that are not matter. I suppose I could also say ideas are not matter. But electrons are matter. Atoms are matter. Jensen is matter. Now note, I said he is matter, not that he does matter.
How about sound? Sound?
So, another good one. Sound.
Oh,
Sound, depending on how we want to interpret that one, sound is not matter because sound is energy, which does not have mass. However, sound is the waves in the air molecules, and the air molecules are matter. Yeah, Jack. Say again. So taste is a response that you have to specific chemicals. So taste senses types of matter, but not exactly. All right, so now we've got an idea for matter here. Our first couple sets fall into a category called pure substances. A pure substance is any substance made up of one type of molecule. Made of one type of molecule. Okay, we can then subdivide pure substances into elements and compounds. Elements, and an element is any matter that is made of only one type of atom.
wait, there's different types of atoms.
Yes. Of one type of atom. So examples for this could be something like hydrogen or oxygen. Okay. When we're talking about oxygen, we can talk about oxygen in terms of the stuff you're breathing right now. That is two oxygen atoms bound together. Or we could talk about oxygen in terms of ozone. Ozone is made of three oxygen atoms bound together. Either way, they are still an element. Yeah, Colin.
Is heat matter?
Heat is the form of energy, so no. Okay, our next one here are compounds. Compounds are matter that are made of more than one type of atom chemically combined. More than one type of atom chemically combined. And when a compound combines elements chemically, those elements lose their own individual properties. So properties of a compound are unique and independent of those of the properties of their constituents. Has unique properties compared to the atoms that make it up. And we can see that with something like water. All right? Somebody tell me some properties of oxygen. What do you know about oxygen? What is oxygen? It's a gas. Okay. So it's a gas at room temperature. Give me more. What do you know about oxygen? It's what? Yeah, at standard temperature and pressure, it's a gas. Okay. What else do we know about oxygen? Oh, come on. You know more than just it's a gas. Give me the obvious one.
Tasteless.
Say again over here. You breathe it. It's breathable. Okay? Anything else? What do you need oxygen for other than breathing? What else needs oxygen to exist? Plants produce it. So produced by plants. Okay? I'm thinking of one more that needs oxygen to exist. Ah, fire. There we go. So flammable. All right. How about hydrogen? What do you guys know about hydrogen? It's a chemical. I also heard someone say it's a gas. So it's a gas at room temperature. What else? Anybody know anything else? Say again. Say again. No, they're different types of elements, so they're very unique. Other thoughts? What else do you know about hydrogen? We'll get there. All right. Well, hydrogen is highly explosive, and it's very light. Okay. So we've got a gas here that's explosive and light. We've got a gas here that's breathable, it's flammable, it's produced by plants. And then we have water, which is, we could also call it dihydrogen monoxide. Dihydrogen monoxide. Which, what that's saying is that the chemical composition of water is 2 hydrogen and 1 oxygen. Chemically combined, it produces its own set of unique properties. First of all, what state of matter is water at room temperature? Liquid. Is water flammable or explosive? Nope. Not flammable. Okay. Is water breathable?
No.
No. Okay? Well, actually, fish don't breathe water either. They process the oxygen out of the water using their gills. So they breathe oxygen too. It's just that they can do it while underwater. Okay? All right, so your attention's back up here. So we've got two individual substances that have their own unique properties, but when we combine them in water, they create something entirely new that has none of the same properties as these two things. It's not flammable, it's not explosive, it's a liquid, nothing like oxygen or hydrogen. Now, aside from our pure substances, we also have mixtures. Mixtures are a combination of more than one pure substance, not chemically combined. Of more than one pure substance, not chemically combined. Okay? You can breathe in a mixture of hydrogen and oxygen if they're both in their gaseous states. This is something that you could then exhale no problem. You'd absorb the oxygen that you needed to exist, and the hydrogen would just come back out. However, a mixture of hydrogen and oxygen, since they both contain their original properties, is highly explosive, and therefore causes things like the Hindenburg, if you are familiar with that disaster. Or we can use it as rocket fuel. Okay? So a mixture of hydrogen and oxygen is rocket fuel. Okay? So in a mixture, they maintain their original properties, and can be separated physically. So what that means is that if we wanted our mixture of hydrogen and oxygen, by cooling it to very low temperatures, we could collect one of them as liquid before the other one. Alternatively, a mixture like a bucket of sand and rocks, you can reach in and pick out the rocks, no problem. Still a mixture. Now, there were 5 different terms for types of mixtures. I heard you guys get 3 of them earlier, including a suspension, a solution, a colloid, and there were 2 larger groups of mixtures. What were the 2 larger groups? Someone who did the notes. Yeah, McKenna. Yep, homo and heterogeneous. Homogeneous and heterogeneous. Those 5 terms are terms that you're going to want to know. Make sure that if you have not already added them to your notes, that you do that. Okay?